Hello and welcome to our computer game programming class. We're going to start this class by looking at rock, paper, scissors game. This is basically an ancient game that is played between two players who simultaneously have to choose one of the three shapes that are available. What shapes are we talking about? We're talking about the rock. We can see the rock here, the rock in red, the rock. We have the paper in blue, and then we have the scissors in green here. So basically, when you're talking about the rock, which is represented by a closed fist, and the paper is represented by open hand or flat hand, and the scissors will be represented by fingers. The two fingers form a V. That is, they represent the scissors. Now, what are the outcomes of this game? The outcome can either be a draw, win, or a lose. Now, you draw if you end up simultaneously outputting the same shape, and you can play the game again to break the tie. And when it comes to win or lose, it depends on the rules of the game. And what are those rules of the game? The gameplay. A player who plays rock here will beat a player who plays scissors, and this is because rock breaks or can smash a scissors, and will lose to a player who plays paper because paper can cover the rock. Rule number 2, player who plays paper will beat a player who plays rock because, as we have said, paper can cover the rock, but will lose to a player who plays scissors because scissors can cut paper. Number 3, we are saying player who plays scissors here will beat a player who plays paper because scissors can cut paper, but will lose to a player who plays rock because, as you have said, rock can smash the scissors. So basically, it's as simple as that. So let's get straight to Java programming and see how these can be implemented through a code. I'm using the Eclipse IDE. I find it very simple to use, to work with. I would recommend it. So kindly, if you do not have this IDE, you can go straight ahead and download it from the internet. It is available free. So it's a very simple IDE. Here we basically have the project explorer, and this is our coding area, and we're supposed to have a console here at the bottom here. Let me get it. Windows show view, and then we have the console. Yeah, some codes that I was running there. Now that's where we will get to see the results of our. That's where we'll get to see the results of our output. So let's create a new project. We basically come to File, then New, then Project. We can give it a name. Call it Game Dev for development. There. Okay. There it is. Now we can right click on it, and I like working with package, so let's create a new package. We can call it com.mpuni. I'll just call it games. Let's call it basic games. Basic games should work better. Now there we have our package here. So we go right away and right click on the package and then come to class. So we are creating a rock paper scissors class. Sorry. Rock paper scissors. Yeah, let's call it rock paper scissors. That's the name of our class, and we'd want this class to come with a main method so that we don't labor type in that method. It's already there, it's just being created, so we remove that. So let's start coding now. Okay, where do we begin? We can work with the scanner to allow us to enter inputs. So it's basically import java.util.scanner. Yeah, that one will allow us to enter our choice. Then we can go straight away to creating the scanner object. Scanner C is equals to new scanner, usually as system dot in. Okay, there we go. Now that we have that, we can set a loop while let's not set it now. Let's first work with we can create an array to store our values. RPS, rock paper string. Then what are the values of these arrays? We can set them. We can set them as rock, R for rock, P for paper, and then S for scissors. Close our curly brace and we terminate. Okay, the next thing is to have the computer choose. You can create this comp move variable, which should be equals to the RPS, since it's an array, and then inside we can talk of new random. You have new random dot next ints, and then what are those values now? What is the size? When you say RPS dot length, of course looking at it, you know the size is 3, but would want it to automatically figure out the size. The moment you say dot length, it's able to compute the size of this particular array we are referring to as RPS. So it will be selecting randomly between those 3 values that are already provided there. So we can create another one for player. Let's work with int player move. Okay, player move. That should be a good one. Now, what we need is a menu. What we need is a menu. How do you put this menu? Okay, you can put it there. System.out.println. Then we can say 1 for rock. Yeah, 1 for rock. Can say 2 for pepper. They would have 3 for scissors. There we go. And then we can say, inform the user, the end user of this application, enter your choice. There it is. Now we need to use the scanner for the user to be able to enter his choice. So we had already created an object C for scanner, so we need to make use of that one. Now how do we go about it? We have the player move. We have the player move is equals to C dot, yeah, dot next int. There. So have we done that? Now we need to make use of the switch. switch control structure. And what are we switching? We'll switch the player move. Player move, there it is. A switch must have opening and closing curly brace. Then we work with cases. So case 1. What is case 1? Case 1 is if what? Comp move dot equals if dot equals 1 is for rock. If it equals what? The R. Yeah, if it is equals R, then definitely we know we are talking about what? We are talking of the game being a tie. Game is a tie. Okay. Let's use else if. Else if what to give the other condition here. Else if we are going to say if comp move dot equal. So you want to know when now this player wins. If comp move dot equals S, is it S? Rock can smash scissors. Yeah, rock can smash scissors. Let me scroll up a bit. Okay. I basically say you win. Yeah, you win. We can use else here at this particular point, and then you lose. You lose. There it is. So we have the first case. If it is R, since you've selected 1, then the game is a tie. We can say try again. Try again. Okay. Okay, so that's what we have, and at the end of every case we are supposed to bifurcate, break there. So you don't need to do this typing again. You can basically just copy and paste there and then change it to 2. So this is a player who selects P. So if it is P, then it is a tie. If computer move is also P, then we say it's a tie. You can try again. But now Pepper wins when what happens? Pepper will always win when the other player move is rock. Else you lose. Okay. There's another move that we need here. Yeah, is the end. We can copy there, paste it there. Is 3. So now we have scissors. Scissors wins when you play what? Pepper. And the next one plays pepper, then you lose the other one, and that's the end of it. I think those 3 are enough. We covered basically everything we're supposed to cover. However, we must obey the structures of the switch statement. We must have a default. Defaults. What's the default? Sorry. You pasted. Just type it. System dot println invalid inputs. That is, you're supposed to enter 1, 2, or a 3. Any other input is an invalid input. So you have a default. Take care of that. Let's see anything that we have not included. I think it's okay. Okay, now let's save and run this See how it works out. What does it say? Error, unresolved compilation. Cannot resolve random. Okay, sorry about that. We use this method random here, and we never provided its importation. So if you basically just point at it, place a cursor on top of it, it gives you these options. So import, it has been imported, it is there. So let's save and run it again. Okay, now it's running. Okay, so one rock, I win. Okay, there's a problem here. We do not know what the computer has selected, so we need a means of first output what the computer has selected. We can come at the end of the switch and do that again. System dot out dot println the computer played. You can see the computer played what? So let's concatenate here. We call it comp move. Yeah, that should work now. Okay, let's save and run it again. Okay, if I select 2, you win. The computer played R. 2 is paper. Paper covers rock. Okay, yeah, that's the truth. Let's run it again. If I select 3, lose. Computer played R. Okay, so instead of running it every now and then, every time that I want to make my own play, what we can do is that we can set a loop so that we can loop continuously. Where do we set that loop? Somewhere. Let's see. So we can just set it here. While true. Yeah, moment we say while true, that's it. So let's see where we're going to add the closing curly. Okay, save. There. You select 3. Okay, you can still without having to run the program again. It's giving me an option. Okay, yeah, I think that basically covers the rock paper scissors game. So it's as simple as that. Look at the code and you can implement this code simple. There it is, because what we have done here, we have set an array. Then the computer is selecting randomly from these arrays, and then we have set an integer variable to hold the value that the player will be selecting. We have given a short menu here where a user is supposed to select either 1, 2, or 3. Okay, there is an input that will allow user to enter his input, and it's of type integer. That's why we have set on next int. Then we have moved on to switch control structure for a decision, and then within it we have basically this nesting. What we have done is that we have nested the decision control structure with another different control structure here using if else if, similar to the switch. But what is happening here is that we're saying the moment we say comp.equals r, whatever computer selected, is it equal to r? If it is equal to r, then there is a tie. Else if it is s, then there is a win. Else will be the other alternative, because if it is not r, if it is not s, then what is it? It's paper. Then you lose. So it's as simple as that. Just interrogate this code, look at this code, try to see if you can implement your own code. Thank you for watching, and bye bye for now.